Good morning to all. This is in continuation with the previous session. In this session, we are going to discuss unit impulse function. In the last session, we discussed unit step function. Let us start. Now we are going to discuss unit impulse function. Unit impulse function. This function too we are discussing with respect to continuous time signal and with respect to discrete time signal. Under these two concepts, we are discussing this unit impulse function. Now let us start. Now, unit impulse function. Impulse function. Its actual function is Dirac delta function. Its actual name is Dirac delta function. That's why it is shown by delta. It is shown by delta function. In the previous case, unit step function is denoted by u of t. Look at unit step function, that is denoted by u of t. But unit impulse function, that is denoted by delta of t. These two differences students have to remember. Now, in the previous case we discussed, this concept is over. Now we are discussing Dirac delta function. Dirac delta function. Now let us consider under continuous time signal. Now let us discuss this one. Now just look at, go for the same graph. This is time axis. This is delta of t. These two unique representations students have to remember. In the previous case, we used u of t. U of t represents unit step function, but here delta of t represents impulse function, unit impulse function. Now on the time axis, this is 0, 1, 2, 3, 4, 5, etc., etc. Here -1, -2, -3, -4, etc., etc., etc. Now just look at, for all the values less than 0, for all the values less than 0, here the output is 0. Look at the thick line. But whenever it reaches 0, suddenly it spikes to an infinite value. It spikes to an infinite value. Infinite value. After t is greater than 0, again all its values are 0. Now just look at, all are zeros. Students have to find out the thick lines. Less than 0, all values are 0. Greater than 0, all values of 0. But at 0 only, suddenly spikes to infinite value. But measuring these, entire its force, its value is equal to 1. It raises suddenly. At how much level it raises, we can't say. That's why we are using the symbol infinity. But measuring the sudden spike at the 0.1 under the limits minus infinity to plus infinity, its value comes under 1. That's why because of 1, we are using unit. Its movement, we can't say at what level it raises. For that purpose, we are using impulse. It is a mathematical representation, so function. Unit impulse function, its actual name is Dirac delta function. How to represent? It's a mathematical model. Delta of t equal to, look at, for all its values is 0 up to less than 0. Therefore, its value equal to 0 up to t less than 0. Whenever it reaches 0, suddenly spikes. We can't measure that one, infinity, when t equal to 0. But after t greater than 0, again its value is equal to 0. Look at. Compare this sketch of Dirac delta function and compare with the mathematical modeling of this Dirac delta function. Look at 0 when t equal to 0. Up to this one, up to it reaches 0, its value is 0. When t equal to 0, suddenly spikes to infinity. But measuring its quantity measure comes under 1. After 0, its value equal to 0. This is called unit impulse function, mathematical modeling of unit impulse function. Now the same concept, now just we are discussing under discrete time signal. Look at under discrete time signal. Now go for the same graph. This is n. This is Dirac delta function. 0, 1, 2, 3, 4, 5, etc., etc. Here -1, -2, -3, -4, -5, etc., etc., etc. Look at the difference. Now, as long as n is less than 0, its all values are zeros. Look at, I am not drawing a thick line. Instead, I am using thick bubbles on the parallel axis, on the time axis, 0. The moment it reaches 0, it suddenly rages to which value? Rages to which one? Rages to up to infinity. But measuring its value equal to 1. After that, for 1 equal to the remaining all values are only zeros. Like this, only zeros. Now just look at the difference between this thick line, as it is in the previous case, represents continuous time signal. It represents discrete time signal. Comparing this one, how are we making? Delta of n, that is equal to 0 when n is less than 0, that is infinity. When n equal to 0, that is 0 when n is greater than 0. Look at this one, same concept. It includes decimal values, it doesn't include decimal values. It always takes of pure integer values. Now, again, one important point between these two is that what is the relation between unit impulse function and unit step function? This is very important. Now, just look at relation. Now, again, students have to look at this one. What is the important relation between unit step function and unit impulse function? Very much important. Now just look at relation between unit step function and unit impulse function. What is the relation between these two? Very much important. The relation between unit step function and unit impulse function. Now just look at, you are integrating minus infinity to infinity of a Dirac delta function, you are going to get unit step function. Very important concept students have to understand. In the previous case, what did we raise? In that graph, what graph did we make it? The moment it reaches 0, suddenly it spikes to which value? Infinity. But we are measuring this value, sudden spike, always equal to 1. That is unit impulse function. That impulse can't be measured. That's why it spikes at some level. That level can't be measured. That's why we're using that infinity. But integrating that infinity values between this function, we always get 1. So what is the important property of this one? So now students have to write the important property of unit impulse function is that minus infinity to infinity, we are integrating any Dirac delta function that is equal to 1. Important property of this point, we have to note it down. Integrating a Dirac delta function between the limits minus infinity to infinity, its value equal to 1 always. The same concept is applicable for discrete property. This is for continuous time signal, property of this one. For discrete time signal, the property of Dirac delta function equal to summation minus infinity to infinity u of, not u, delta of n, that is equal to 1. This is important property of Dirac delta function under continuous time signal. This is the important property of this Dirac delta function under discrete time signal. These 2 points you have to note it down. After that come this one. What is the relation between unit step function and unit impulse function? It is step, that is impulse. The between values, the relation between these two values is equal to integrating a Dirac delta function between the limits minus infinity to infinity with respect to the time variable, its value is equal to u of t. This is very important concept, the relation between unit step function and unit impulse function. Now from this one, how to get Dirac delta function, how to get delta t, Dirac delta function. That means differentiate both sides with respect to time variable t. Then what happens? d by dt of integral minus infinity to infinity delta t of dt, that is equal to d by dt of what? U of t. Now this differentiation and this integration both gets cancelled. Therefore its value equal to delta of t equal to u of t differentiation dash u of t. Students have to remember this one. This principle and this principle, these two are very much important. What is the relation between Dirac delta function and unit step function? Now just look at that is the property of Dirac delta function under continuous time signal. There is the property of Dirac delta signal under the property of discrete time signal. Now what is the relation between these two? Integrating a Dirac delta function between minus infinity to infinity with respect to time variable always gives unit function. Again, differentiating unit function, it gives impulse function. Students have to make this property very important. Now just look at unit step function. This is unit impulse function. Now to get unit step function, from unit step function what you get? Unit step function. Now here from unit step function you can get this one. So if unit impulse function is given, by integrating you will get unit step function. By differentiating unit step function you will get unit impulse function. Look at the difference between these two concepts. That is very much important for students' examination point of view also and conceptual basis also. The next session we are going to discuss exponential function. Thank you.